Welcome to qnawire.
Okay, in this problem, we are asked to compare values from a barometer. So we know that at room temperature, the pressure of mercury is 0.0015 millimeters mercury. And at sea level, the height in a barometer is about 760 millimeters. And part A of this problem asks, if we just neglected the mercury, would the atmospheric pressure be greater than, less than, or equal to this value of mercury? We're then asked to actually compute a percent error, so this is quantitative. And then finally, we're asked for a percent error if we use the standard temperature pressure of water vapor. So to start, for part A, true atmospheric pressure will be greater than the reading from the barometer. So if we look at figure 13-11, if there's vapor pressure at the top of the tube, then the vapor pressure is going to be equal to atmospheric pressure minus rho GH, which is the pressure of air pushing down. So the reading from the barometer, what you're actually going to see is rho GH, which is just going to be the difference between atmospheric pressure and vapor pressure, which is necessarily going to be less than atmosphere because pressure from the vapor is non-zero in this case. So just a little bit of conceptual difficulty there, but the actual math is relatively straightforward. Now, to get a percent error, we just take rho GH minus atmospheric pressure over atmospheric pressure. And of course, you got to multiply that by 100, no problem. And this is the same, and remember this difference is the same thing as vapor pressure by definition in part A. So what we're dealing with is 0.0015 millimeters mercury. And we have to get atmospheric pressure millimeters mercury, which it turns out to be 760, which we can just look that up. So our value is going to be about 2 times 10 to the negative 4%. So it's a very small percentage, meaning that it's justified to neglect this pressure of the mercury vapor pressure. Okay. Now let's look at it for saturated water vapor pressure. So at STP, we can consult table 18-2. And for room temperature, we would see the water vapor pressure, PV, we'll call it, is 611 Pascal. So once again, we can get a percent error, percent difference, which would once again be PV over PATM, atmospheric pressure, except we just change the value of the vapor pressure. It's negative 611 Pascal. And then we get atmosphere in pascals, which is roughly 1 times 10 to the 5. So you can already see that this is going to be larger than the previous answer, but still really small because you're dividing by 10 to the 5. And we end up with, of course, multiply by 100. We end up with 0.603%, so less than 1%. So that's more significant than mercury, but still not particularly significant. So that's it. Consulting some tables, and that's it.